July 24th, 1943. The skies above Hamburg are clear, the moon 3/4 full, and somewhere below in a darkened control room, a German radar operator named Nobody Remembers stares at his screen in disbelief. The display, which should show a tidy formation of British bombers approaching from the North Sea, is instead a blizzard of white static. Hundreds of echoes bloom across the scope, overlapping, multiplying, refusing to resolve into anything he can plot. He adjusts the gain. He recalibrates. Nothing helps. Somewhere above him, 791 Royal Air Force bombers are converging on the city, and his radar, the pride of German engineering, the Würzburg and Freya sets that have guided night fighters to their targets for 2 years, can no longer see them at all. He does not yet know what is falling from those aircraft. It is not high explosive. It is not incendiary. It is something far stranger. Tens of thousands of strips of blackened paper backed with aluminium foil, each one cut to a precise length of 26.5 centimeters, tumbling from the bomb bays in their thousands, drifting on the night air like a perverse kind of confetti. The British call it window. History will remember it as chaff. And on this night, over this city, it will help make possible one of the most devastating air raids of the Second World War, codenamed Operation Gomorrah, while costing the lives of remarkably few of the men who dropped it. This is the story of how a few strips of paper and metal blinded an entire national air defense system, and why the men who invented it were almost not allowed to use it at all. To understand why something so simple mattered so much, you have to understand the problem Bomber Command faced by the autumn of 1942. Britain's strategic bombing campaign against Germany was, by any honest measure, failing. The Butt Report of 1941, a piece of internal analysis so damning it was kept quiet for years, had found that only one bomber crew in 3 managed to drop its bombs within 8 kilometers of the intended target, and that figure dropped further for raids deep into the Ruhr. Navigation at night, over blacked-out cities, in aircraft battered by flak and harried by fighters, was extraordinarily difficult, and German air defenses were getting better every month. That improvement had a name, or rather several names: Freya, an early warning radar that could detect aircraft up to 160 kilometers away, and Würzburg, a more precise gun-laying and fighter control radar accurate enough to guide a night fighter to within visual range of a bomber in total darkness. By 1942, the Germans had woven these systems into something called the Kammhuber line, a belt of overlapping radar zones and searchlight batteries stretching from Denmark to the French border. Each zone handed a bomber like a baton in a relay race, tracked by ground control, guided by radar-equipped night fighters such as the Messerschmitt Bf-11O fitted with Liechtenstein airborne radar. Bomber losses climbed accordingly. By the spring of 1943, on the hardest-fought nights, losses could reach 5, 6, even 7% of the attacking force. Numbers that, sustained across a tour of 30 operations, meant a bomber crew's odds of survival were worse than a coin toss. The frustrating part was that British scientists already understood, in principle, how to defeat this system. As early as 1937, a researcher at the Bawdsey Research Station, R.V. Jones, had noted that thin strips of metal foil, cut to roughly half the wavelength of a given radar signal, would resonate with that signal and throw back a false echo many times their own size. Drop enough of them and you could swamp a radar screen with thousands of phantom targets, hiding real aircraft inside a fog of false ones. The principle was simple. The politics were not. Both Britain and Germany had independently discovered the trick, and both, terrified that using it would simply teach the enemy the same lesson, sat on the secret for years. Churchill himself had to be persuaded. It took the deteriorating bomber loss rate, mounting pressure from the air staff, and dogged advocacy from scientists, Jones prominent among them, before the decision was finally taken, in the summer of 1943, that the gain was worth the risk. The Germans, it later turned out, had developed an almost identical device they called Dupel, named after the village near Berlin where it was tested, and had likewise been forbidden from using it for fear of revealing it to the British. Both sides had been sitting on the same weapon, paralyzed by the same fear, for the better part of 2 years. The technical work behind what the British called Window was carried out chiefly at the Telecommunications Research Establishment, the TRE, then based at Malvern in Worcestershire, the same institution responsible for much of Britain's wartime radar development. The team, working under the close interest of Jones and with the backing of figures including Frederick Lindemann, Churchill's scientific advisor, had to solve a deceptively fiddly engineering problem: how to mass-produce a strip of foil-backed paper that would resonate precisely with the German Würzburg radar, which operated on a wavelength of around 53 centimeters, while also working against the longer wavelength Freya system. The answer, arrived at through testing at TRE and trials over the Norfolk coast, was a strip measuring 26.5 centimeters long and 1.5 centimeters wide, made of black paper with a thin layer of aluminium foil bonded to one side. Picture a bookmark or a strip cut from a chocolate bar wrapper, and you have roughly the size and weight of a single piece of window. Dropped from a bomber at altitude, a bundle of these strips would be released by an air-bursting cartridge or simply pushed out by hand through a flare chute, and the strips would tumble and flutter downward, each one acting as a tiny dipole antenna, catching the radar pulse and re-radiating it back toward the ground station with startling efficiency. A single Lancaster carrying a few hundred kilograms of window, released at a steady rate of around 1 bundle a minute, could generate a radar return on the ground equivalent, by some calculations, to dozens of aircraft. Multiply that by the hundreds of bombers in a typical raid, all dropping simultaneously, and a German controller's screen did not show a formation of aircraft requiring careful tracking. It showed an impenetrable wall of white noise. Production was handled with deliberate, almost mundane ordinariness, partly as a security measure. Vast quantities of the foil strips were manufactured by British paper and packaging firms, with women workers in factories across the country cutting, gluing, and bundling foil to paper, often without being told precisely what the material was for. Estimates of total wartime production run into the billions of individual strips, though precise figures remain difficult to verify given the compartmentalized and often informally recorded nature of the work, and many records were not preserved with the rigor applied to more glamorous wartime projects. What is well documented is the rate of use. During the Hamburg raids alone, RAF bombers dropped an estimated 92 million strips of foil over the course of the operation, a number so large it is almost easier to grasp by weight than by count. Several tons of paper and aluminium scattered across the night sky above a single city in a single week. The deployment, once authorized, was almost anticlimactic in its simplicity. Aircrew were issued bundles of the strips, briefed with a one-word code name, and told to push them out of the aircraft at a steady rate over hostile territory, typically through the flare chute near the rear of the fuselage, a task often assigned to the wireless operator, or, on some aircraft, the bomb aimer. There was no elaborate machinery, no special bomb bay modification required in the early operations, just men in cramped, freezing aircraft posts, feeding handfuls of paper strips into the night for hour after hour. The results on the night of July 24, 1943, the opening raid of Operation Gomorrah, were immediate and, to British planners, almost too good to be true. German night fighter controllers, accustomed to a screen showing perhaps a dozen distinct returns that could be matched to known bomber streams, were suddenly confronted with hundreds of simultaneous echoes. Fighter controllers, unable to distinguish real aircraft from false ones, struggled to issue coherent vectors to their night fighters. Anti-aircraft batteries relying on radar-directed predictors for their gun-laying found their equipment producing wildly inconsistent solutions. Loss rates for that raid fell dramatically compared to what planners had projected and compared to recent raids over similarly defended targets, with documented losses of roughly 12 aircraft from the attacking force, a fraction of what the Kammhuber line had been inflicting on less protected raids only weeks earlier. German night fighter pilots, debriefed after the raid, reported confusion, frustration, and in some recorded accounts a kind of bewildered fury at instruments that had simply stopped making sense. Exact contemporaneous German technical assessments of that first night remain incomplete, much of the documentary record having been destroyed or scattered in the chaos of the following years. But post-war interrogations of Luftwaffe radar personnel consistently describe the period as one of the most disorienting of the entire war for the German air defense network. If you are finding this interesting, a quick subscribe helps more than you know, and it costs nothing. The comparison with the German equivalent, Dupel, is one of the war's neater ironies. German engineers had reached almost identical conclusions years earlier, testing strips of foil against their own Würzburg sets and confirming the same vulnerability the British had found. Like the British, German High Command refused permission to use it operationally, reasoning that Germany's defensive advantage from radar was, on balance, more valuable than the offensive advantage foil dropping might provide over Britain, whose air defenses by 1943 were less dependent on radar interception than Germany's were becoming. The result was a strange standoff in which both air forces possessed the countermeasure and both refrained from deploying it, each side unaware that the other had reached precisely the same technical conclusion by precisely the same route. When the British finally used window over Hamburg, German engineers reportedly recognized the principle within days, having tested the identical concept years before, and rushed to deploy their own stocks of Dupel in retaliation, used in raids against British targets later that same year, though by then Britain's air defenses, having anticipated this very possibility, had already begun adapting their radar and control procedures to cope with foil interference. American forces, flying daylight raids as part of the combined bomber offensive, adopted the technique under the name Chaff, not long after the British began using window, recognizing its value for protecting their own heavy bomber formations from German flak control radar, though the tactical application differed somewhat, given that American operations relied more on visual bombing in daylight and faced a different mix of threats. British window, used primarily to confuse night fighter control and gun-laying radar in the dark, and American chaff, often used to blind flak batteries during daylight raids deep into German industrial regions, would together come to define one of the most cost-effective countermeasures of the entire war. A few pence worth of paper and foil offsetting systems that had cost the German war economy a fortune in research, manufacturing, and trained personnel to build. Assessing the precise impact of window on the war's outcome requires some honesty about the limits of historical evidence. What is not in dispute is that the technique sharply reduced Bomber Command's losses during the period of its introduction, with casualty rates for raids using window over the following months running noticeably lower than the punishing figures of the preceding winter, even as raids grew larger and pushed deeper into Germany. What is harder to quantify is how much of that improvement came from window alone, as opposed to other countermeasures introduced around the same time, improved fighter escort, and changes in German tactics. Historians generally agree that the psychological effect on German radar and fighter control personnel was at least as significant as the purely technical one. An entire defensive system built around confidence in its own precision suddenly rendered, for a period of months, unreliable and demoralizing to operate. The Germans scrambled to develop new radar frequencies, more sophisticated filtering techniques, and ultimately a shift toward visual and infrared methods of night interception, an entire branch of German wartime technical development effectively forced into existence by a few thousand tons of foil strips. Examples of original window bundles, along with related TRE documentation, survive today in the collections of the Royal Air Force Museum and the Imperial War Museum. Modest little artifacts that look, even now, almost too ordinary to have changed the balance of an air war. So return for a moment to that German radar operator on the night of July 24, 1943, hunched over a screen full of meaningless light, trying to do an impossible job with instruments that have, in the space of a single hour, become useless. He does not know that the strips falling outside his window, scattering silently across rooftops and gardens and the dark waters of the Elbe, will be picked up the next morning by curious civilians who have no idea what they are looking at. He does not know that the men dropping them, exhausted bomber crews who have flown for hours through flak and fear, will return to England having lost far fewer comrades than they expected to lose. He knows only that the machine in front of him, the machine he has trusted, the machine an entire nation's air defense has been built around, has gone blind. That is, in the end, the whole story in miniature. Not a death ray, not a wonder weapon, not some impossibly complex piece of engineering beyond the reach of any rival power, but a few centimeters of paper and foil, cut to a precise length, dropped by the thousand, that achieved what years of expensive radar development on both sides had been built to prevent. It worked because it was simple. It worked because both sides had discovered it, and both sides had been too frightened of its consequences to use it. It worked because, in the end, modern war is often decided not by the most complicated invention available, but by the willingness to use the simplest one at the right moment. A blizzard of paper, falling silently through a summer night, blinded the most advanced air defense network in the world. Sometimes the quietest weapons make the loudest difference.